हेलो, अस्सलाम वालेकुम।
वालेकुम सलाम।
कैसी चल रही है बासित आपकी तैयारी?
तैयारी अच्छी चल रही है। मैं अक्टूबर नवंबर के पास पेपर 3 साल आगे हो गए हैं।
ओके, गुड। हेलो, अस्सलाम वालेकुम जोया, हाउ आर यू? Okay, let's begin. We have to continue from transition elements. We have discussed regarding group one metals yesterday, and group seven halogens we discussed yesterday, and basics of periodic table regarding electronic configuration and how the general trends work. Okay. Now, as we move on to transition elements, you need to know that in transition elements, the reactivity, and they are more, you need to know the general properties, the physical and also the chemical properties. Amongst the physical properties, they're very hard, they're very strong, and they're also good conductors of heat and electricity. They, as compared to any other metal, okay? So for instance, if we discuss group one elements are very soft metals, right? They can be easily cut using a knife. Whereas transition elements, they are higher in density and they are very hard and very strong. You cannot easily cut them using a knife. And we also have higher melting and boiling points. Why is that so? Because the greater the electrostatic forces of attraction are present, the greater would be their melting point as compared to group one or any other group two metals. Okay. So, for instance, if usually that the questions that come up in exam, they involve, they give you a certain table. They ask you pick any element which you think is going to be or aligns with the category of the transition element or aligns with the category of group one metal. So you have to look into these physical and chemical properties. Transition elements, they're also very reactive. But group one and group two metals, they are more reactive as compared to transition elements. Okay. When you look into transition elements, they have a very distinct characteristic of forming colored compounds, and that is because of colored complexes that they can form. Okay, they can have more than one oxidation state. This means that one particular group one metal, for instance, is only able to donate its or lose its one outermost shell electron only, right? But transition elements, they have a tendency to lose more than one electrons. Okay. And you will study this why in A levels, that transition elements, they have different characteristics and as such features within their atomic structure, which is why they are able to donate more than one electrons, which is why as a result of which they have more than one oxidation state. For example, copper can be a copper metal. It can be copper 1 plus, it can be copper 2 plus. Similarly, iron can be Fe2 plus, it can be Fe3 plus as well. Because of these varying oxidation states, their compounds, they're also colored. For example, copper as a metal is pinkish brownish solid. Okay. Whereas copper 1 plus compounds, they are green in color. Copper 2 plus compounds, they tend to be blue in color. Okay. Similarly, Fe3 plus is found in rust. So it is brown in color. The color of Fe3 plus precipitates are also brown. But Fe2 plus, they are green in color. Okay, so how do we remember these colors specifically regarding these? You just need to know the common colors for the transition elements, because sometimes they're also asked in the paper. For instance, like chromium, manganese. Okay, Fe3 plus is present in rust. Rust is brown, which is why this Fe3 plus is going to be brown in color. Its compounds, they're all going to be brown in color. Its precipitates, they're all brown in color. Fe2 plus is going to be green on the other end, right? Now, transition elements, they are often used as catalysts. They are very good catalysts. For example, when we were doing the chemical equilibria, we studied a Haber process, and in that we said that nitrogen reacts with hydrogen to form ammonia. During this manufacture of ammonia, iron is used as a catalyst. So this iron is basically a transition element, and transition elements, they are very good catalysts. Okay, they have pigments, which is why they're used in gemstones, in certain rocks, in many paints and everything else. Other than this, you have car exhaust. catalytic converters. Okay, the catalytic converters which are present within the car exhaust, they have platinum, palladium, or rhodium as the catalyst which are used. Okay, so these basics you need to know regarding transition elements. Transition elements, they are found within between the metals and the non-metals within the periodic table. Okay, and these are the basic colors that you need to know. For vanadium, you must know some of these colors. Okay, for chromium, you need to know chromium 6 plus is orange, 3 plus is green in color. Manganese 7 plus is pinkish in color, and 2 plus is colorless, pale pink. Iron Fe3 plus is brown in color, which is present in rust. Fe2 plus is green in color. Cobalt is 2 plus, which is pink, and nickel is 2 plus, which is green, and copper 2 plus is blue. Copper 1 plus forms green colored compounds. Okay, so mainly the factual things which are usually asked in the paper, which is basically marks scoring, is these uses of the transition elements or any of these elements. They can ask you that these are also used in or what applications do you see. So you can say that they are used in medicine and surgical applications, for example in limb and joint surgeries, and titanium is used there. Okay, then in dyes, in paints, and in stained glass jewelries they are used. Okay, they are used as catalysts. This is also one of their uses. Moving on to noble gases now. Noble gases, they're group 8 or group 0. As group 8 suggests that it has a total set of 8 electrons in its outermost shell. They're basically non-metals, they're colorless gases, and they're monatomic. We discussed this yesterday. Mono means one, and atomic refers to the atom. So it's basically single atoms. They are inert, they have a full outer shell, they're extremely stable, so they are completely unreactive. They have very low melting and boiling points. Okay, and helium is one of the elements here, which only has one shell, which is why it only has 2 electrons in its first shell, and that's the only shell that it has. The uses of the noble gases you need to know. Helium, they used it to fill balloons and in airships. It's basically lighter than air and does not even catch fire. Argon is used in tungsten light bulbs. This question has appeared in exam, that for instance, if you're using within the light bulbs, why do we use argon in tungsten light bulbs, and why not air? Can someone answer me? If air is used within as a filler in the tungsten light bulbs, what is going to happen and why argon is preferred? Yes, Rayhan.
The oxygen will react with the tungsten and cause it to burn, but argon is in group 8, so it's inert, so it will not react.
Yes, very good. The oxygen which is present in atmospheric air, basically it is going to react with the tungsten filament present within the bulb, as a result of which it is going to wear off or it is going to corrode away. So argon, being inert or unreactive, is the preferred choice. So to protect these tungsten filaments within the light bulbs. Other than this, it is also used to protect metals that are being welded, so that it does not react with the hot metal. Neon is used in advertising signs. Krypton is used in lasers, for example, in eye surgery and car headlamps. Xenon gives a light, like bright daylight. So it is used in lights for hospital operating rooms or car headlamps or lighthouse lamps. Okay. This is most of it regarding the periodic table. Do we have any questions by far? Yes, any questions by far? No questions. Shall we move on to the next one? Okay. Okay, yesterday I have sent you some worksheets in the group as well. Please try to solve them at home and whenever you have time at hand. And then share those worksheets with me so I can check and then I can evaluate. Okay. Since we have very less time in the classes, so it's uh, and these are revision sessions, so we will discuss the yearly papers afterwards. But to do topicals side by side, it's very difficult. Okay, to adjust it during the class. So solve them at home and then get back to me if you are whenever you are done. Okay. Moving on to metals now. So metals, we have discussed some of the things. We said that metals, their physical properties are that they're shiny, they're good conductors of heat and electricity. And why are they good conductors of heat and electricity? Because they have delocalized electrons, they are high density, and that is particularly because of the compact arrangement of the metal cations which are present within, regularly arranged within their structure. They're solids at room temperature. They're malleable and ductile, which means that they can be drawn and they can into wires, and they can also be shaped. They are sonorous, which means that whenever they are going to be struck with something, they are going to make a bell-like sound. Okay, so these are certain physical properties regarding metals. If you look into the structure of any metals, they are usually the giant structures. Okay, and they're very strong metallic bonding. And this metallic bonding is basically the electrostatic forces of attraction present between the positive cations and the negative C of delocalized electrons. So you see the positive cations and the delocalized electrons, they are present and they are able to move within the structure of the metal, as a result of which making them a good conductor of heat and electricity. And also this electrostatic forces of attraction present between these is going to help it to have very strong metallic bonding. Okay, so most of these metals, they have high melting and boiling points. And if we compare metals, they have higher melting and boiling points as compared to group 1 or group 2. Their layers of the atoms or the metal cations is easily able to be slide upon each other. Okay, so this makes them have this property of being malleable. Why are they very easily able to slide upon each other? Because they are all same sized metal cations, right, or metal atoms. So these atoms, they're easily able to slide upon each other, and as they are arranged in layers. Okay, when they slide upon each other, their electrostatic forces of attraction weaken and breaks apart with the previous electron, but it automatically regenerates with another new electron, as a result of which this metallic bonding remains intact, and as a result of which they also have this property of being malleable, which means that they can be easily drawn into, they can be easily bent, and they can also be easily shaped. Okay, is this point clear so far? Okay, moving on. Metals, they lose electrons, they tend to lose electrons. We know it, they have a greater tendency to lose electrons, as a result of which they form positive ions or cations. They also gain oxygen, and those reactions are referred to as oxidation reactions. These metals, when they lose oxygen, those reactions will be referred to as reduction reactions. Okay, the general reactions you should know, because these are important. When you will be able to actively recall general reactions, you will be able to solve any kind of a question regarding chemical reactions. Okay, so just memorize these general reactions. For instance, metals react with acid. And whenever any metal reacts with acid, it is going to form salt, and hydrogen gas is produced as a result. So for example, if I say aluminum is reacting with hydrochloric acid, this means that the salt is going to be produced. The formula of the salt is in two parts. The first part is the metal, And the second part is the anion part of the acid. So the anion part of the acid was the chloride, and the metal was aluminum. So you got aluminum chloride. Okay. You're going to swap their valencies to get to know the resultant formula. So it's going to be AlCl3. Are we clear? So first, always write down whatever is formed as a result. So you're going to mention salt and hydrogen, which is produced as a result. And later on, you're going to balance the whole equation. Never leave the chemical equation unbalanced, okay? Because it is going to give a very bad impression, and the chemically unbalanced equation loses 1 mark, okay? Metals, when they react with oxygen, they form metal oxide. And whenever they react with cold water, they produce metal hydroxide and hydrogen, all right? But when you have certain less reactive metals, they do not react with cold water because of less activation energy which is present, as a result of which the reaction does not proceed. So metals, they tend to react with steam, because in steam the activation energy is much greater, and the average kinetic energy is also greater, which is why the product is formed, and the product will be different from cold water. Okay, in cold water, metal hydroxide is formed along with hydrogen. In reaction with steam, only this metal hydroxide is changed to metal oxide. Hydrogen still remains the same. Okay, so hydrogen is produced, but in steam, metal oxide is produced, and in cold water, metal hydroxide is produced. Okay, zinc, for example, sodium. Acha, how do we know that did I discuss the metal reactivity series earlier in some other class?
Yes, miss.
I did. Okay. So maybe I told over there that how do you remember the metal reactivity series? You either make a mnemonic or something, but to generally be able to answer questions, you should know that group 1, group 2, and group 3 metals, they lie at the top. Okay. Then you have carbon, and then you have some transition elements, right, in which you have zinc, lead, iron, and then you have hydrogen, after which you have copper and silver, gold, platinum. Okay, so all of these, they are the less reactive or naive metals, right? So you can divide this reactivity series into 3 groups. This is the first group, this is the second group, in between carbon and hydrogen, and below hydrogen. So we're going to discuss this. Why is this important? This is very important. So to understand the extraction of different metals and their chemical reactivity and everything. For instance, let's take the most reactive metals. Most reactive metals, they are group 1. We said that group 1 is the most reactive. So they are going to readily react with cold water to produce their own hydroxide and hydrogen. But as we go down the group, between carbon and hydrogen, these elements, they tend to react with steam rather than reacting with cold water. So as a result of which, they produce metal oxide and hydrogen. Below hydrogen, these are very naive metals. Okay, so they are very, very less reactive. So these metals, they do not react with cold water, and they whenever they are reacting with, if you make it react with, like for instance, copper or silver or gold or platinum, if you make it react with the acid as well, simply their elemental states reacting with the acid, they are so less reactive that they're not going to give you any product when they react with the acids. This means that copper, any reaction which says that copper reacting with sulfuric acid or HCl, this is going to produce no product. Okay, why? Because copper is very less reactive, and it is not going to be able to displace hydrogen from its acid, as a result of which you're not going to get any kind of a product. Moving on, alloys, they are a mixture of 2 or more metals, and it can also be a mixture of 1 or more metals with along with one non-metal. So alloys, they are, as compared to simply pure metals, they have different properties. Alloys are made to to give different property, like being, as they are very hard, they're also resistant to corrosion. So compared to pure metals, and this property lies because of the presence of different size atoms. I said that different metals are combined together, as a result of which making a new alloy. Okay, so the presence of these different size atoms makes the layers very less mobile, right? If you look into a pure metal, they're all same sized atoms, so they're easily able to slide upon each other even if you apply a certain force. But when you have different size atoms, they are not easily able to slide upon each other, making their layers less mobile and preventing them from sliding upon each other. This makes them the property of being hard as compared to soft pure metals, and also making them more resistant to corrosion. Okay. A few things that you need to know. Brass is a mixture of zinc and copper. This is usually asked in the paper. Mild steel is iron and 0.3% of carbon, and stainless steel, which is usually used in your stainless steel cutleries or in surgical equipment. This is iron. It has iron, nickel, and chromium. Iron is the main counterpart, and nickel and chromium, they are present in less quantities as compared to iron. Is this point clear so far up till now? Yes.
Yes, miss.
Moving on, so this is your reactivity series, and it says that the most reactive metals at the top, and the less reactive metals, or the least reactive ones, at the bottom. It can be divided in two phases. This is your up till carbon. So any elements which are present above carbon, they're more reactive than carbon. This means that they are going to react so readily with anything around them. So they are going to form compounds, and will, or they exist as compounds on the planet. So if you want to extract them, it is difficult to extract them, as a result of which you cannot use carbon to extract or simply reduce their compounds, right? To simply extract these metals by reduction reaction with carbon. So what do we do is, we use the process of electrolysis to basically extract these metals. Okay, any element which is present below carbon can be easily extracted by reduction of with the carbon. Okay? Then you have hydrogen, and below hydrogen, these are the least reactive metals. So these least reactive metals, they are simply naive, and they don't really react um, with the to form compounds, as a result of which they're simply found as their elemental states. So these elements, they are found as elemental states. The first top category is the most reactive, is extracted using electrolysis, and this middle category is basically the one which is extracted using reduction with carbon. Okay, so they form their ores. Okay, they form their metal ores, and these ores, they have greater quantity of the main metal, which is which has usually reacted with the oxygen within the atmosphere to produce um, new, a new metal ore. Okay, or their own metal oxide. So the metals, in their order of reactivity, they have different reactions. You should know this. What is asked in the exam paper, the observations will be asked. You must know how violent the reaction is, or whether it is slow, or whether it is a quick reaction, or whether no reaction takes place. Okay, so you need to know these things here. A bit of memorization is required. It is better that you keep reflecting to this table, or just make your own summarized table of this, so to be able to actively recall this thing. Okay, so for instance, let's look into the first one. The first metals, they are potassium and sodium. Now these two, they belong from group 1. Okay, so let's just talk about group 1 in general. Group 1 metals, which are the most reactive, they will have very violent reaction with cold water. Okay, and that is because of their greater reactivity. Similarly, they will not be reduced, their oxides will not be reduced by carbon, right? If anyone is not getting the concept, right? So just ask me. I'll be there to help. I'm So I'm repeating myself. I said that group 1 metals, they're so reactive that they tend to have very violent reaction, be it cold water or be it dilute hydrochloric acid. Okay. Whereas their reduction of oxide with carbon is not possible. Okay. Because they are very reactive and they can only be extracted using the process of electrolysis. Moving on to group 2. In group 2, you have calcium and magnesium. Calcium and magnesium, magnesium actually reacts very slowly with cold water, but it reacts very readily with steam to produce metal oxide, that is magnesium oxide. Calcium, on the other hand, is going to quickly react with cold water, and both of them, they have a very vigorous reaction with dilute hydrochloric acid. Then moving on to zinc. Zinc does not have any reaction with cold water, but does react with steam. I told you this is the middle part that we're doing. Then it does have a moderate reaction with hydrochloric acid, and it is also reduced to zinc when it is heated with carbon. So by heating with carbon means that, for instance, you have a crucible and you place in the zinc oxide, and you add in some carbon to this. Okay. And then you're going to heat it up. So using a Bunsen burner and just place a lid on top of it. Then this carbon is going to react with the zinc and since carbon is more reactive than zinc, so it is going to displace zinc from its own oxide to produce zinc. So this means zinc loses its oxygen, as a result of which we say that it has been reduced. Any compound which is, or any species which is losing its oxygen to produce zinc or any other simply element, it is going to be your reduction reaction. Whereas on the other end, you see that carbon is going to react with oxygen to produce carbon dioxide, and we say that the oxidation reaction has taken place. Carbon has been oxidized to form carbon dioxide. Up till here, do we have any questions? Yes. You can write in the chat box if there are any questions, or just say something. Yes, Basit, clear?
Yes, Miss Clear.
Okay. Ishil, what about you? Ishil, are you around? Achha. So moving on, any elements which are present below hydrogen, we said that they are very less reactive, they are naive, so they do not really need to react, okay, with anything. So copper does not need to react with anything. It's going to have no reaction with either cold water or steam, no reaction with the dilute hydrochloric acid, and copper oxide will be or can be reduced by heating with carbon. This is copper. Okay. So you can heat them with carbon to simply extract the copper metal. However, generally they tend to be found as in elemental states. Okay. This is another table to help you understand the reactions with the dilute acid or with the air. And with water, we have done already with water. Ease of extraction, we have gone through this. Looking into the reaction with air or oxygen. So group 1 metals, they burn very brightly and vigorously because they're very reactive. Then as you go down the reactivity series, you see that the metals, they do burn to form an oxide, but that vigorous reaction decreases. Okay, they become less vigor. Okay, and as you go down, as a result, below hydrogen, they are not going to react, and or the reaction is going to be completely very slow to form their own oxide. So metals, whenever they react with oxygen, they're going to form metal oxide. Metals, when they react with any dilute acid, they form salt and hydrogen. Metals, when they react with water, cold water, it is going to be metal hydroxide and hydrogen. When they react with steam, they are going to form metal oxide and hydrogen. Is this point all clear so far?
Yes, Miss.
Okay. If we talk about one thing which is very distinctive of no other metal but only true for aluminum, aluminum is very reactive actually. So it readily reacts with oxygen within the air, and it produces its own protective aluminum oxide layer onto its surface. Okay. Because of this formation of the oxide layer onto its surface outside aluminum metal, because of reacting with oxygen, this layer that it is going to form around itself, it is going to basically prevent further aluminum which is present inside this aluminum metal, which is present inside, to react with more oxygen. So it basically, apparently, it tries to show that or exhibit that it is actually unreactive, but it disguises its true reactivity, you can say. So aluminum is very reactive. It reacts with oxygen, but it forms a protective oxide layer on its surface, as a result of which apparently showing that it is basically less reactive. However, it is not. So this is very distinctive and only true for aluminum metal and none other. Moving on to the next one, we've discussed this these kind of reactions where carbon is able to displace the metal from its own oxide, and this is referred to as a reduction reaction, or the reduction of the oxide by carbon, and that is where you heat carbon. Okay. The displacement reactions, this is very important. Metal displacement reactions, for example, you have zinc solid. Zinc solid reacts with the copper to sulfate aqueous solution, and zinc, since it is more reactive, so it is going to, so more reactive metal, the one which is more reactive will be displacing the less reactive one, and if it is displacing the less reactive one, it is going to form its own aqueous ions. For example, if magnesium displaces zinc, so this magnesium is going to form Mg2 plus ions, and it is going to lose its 2 electrons. So the more reactive the metal is, they have greater tendency to lose electron, and or you can say greater tendency to get oxidized. Okay. What happens to these electrons? These electrons, they are gained by the aqueous ion of zinc, and they get themselves reduced to form zinc metal. Okay. Same goes here in this case scenario. Zinc reacts with copper to sulfate. It produces zinc sulfate. So zinc sulfate here, in this case scenario, it is going to be Zn2 plus, and copper solid is deposited as a result. Now, can anyone tell me what will be the observations here in this case scenario? What are the observations for this particular experiment? For this one? Yes. Yes, Zoya.
A blue solid will be seen in the solution.
Which solid?
A blue solid.
Blue solid. Okay. Why do you say it is a blue solid?
Because copper will be deposited. which is
Copper.
blue.
Copper is pinkish solid, or you can say it is brownish solid. Okay, so one observation, all right, and anything else? Basit.
Miss, brown precipitate is formed and zinc sulfide, zinc.
Zinc sulfate. What is the color of zinc sulfate?
Zinc sulfate.
What is the color of copper to sulfate?
Blue.
Blue. So blue is going to decolorize. That blue
Yeah.
color is going to decolorize because of the formation of zinc sulfate. So we say that blue color changes to colorless. Okay. And copper deposits, or you can say solid brown deposits, they are seen or observed. Whenever we are discussing anything regarding observations, we mention only that what we are able to see from our eyes. Okay, what we are observing. This could be metal disappearing. Okay, or we are going to say that the solid is going to disappear. Okay, and a new solid deposit, if it has a distinctive color, you're going to mention that this colored deposit is formed, or this colored solid deposits are seen or observed. For example, here you can say that zinc metal disappears, or you can say that zinc solid disappears, or it gets smaller. And you can say that copper 2 sulfate is, since it is blue in color, so you can say blue color is going to decolorize, or it turns to colorless. You can also say that pinkish brownish or brown solid is deposited, but don't mention that it is copper or something else. Okay, unless and until they say, or they ask you, the examiner says to identify what is formed. Okay, then only you have to say that copper is formed or this is the product. All right. Yes, Ahmed says that zinc disappears. Yes, this is right. So did you get this point so far, everybody? Okay, here in this case scenario, what happens? Zinc is a solid. It is reacting with magnesium chloride, but in aqueous solution. Zinc is less reactive than magnesium, so it cannot displace magnesium from its aqueous solution. So no reaction will take place. Another dimension of the question that the examiner asks is, one dimension is this, that they can ask you simply metal displacement reactions. They will ask you either to form a complete whole ionic equation or half equations like this, and like this that I told you. Then observations can be asked for the particular reaction, or to complete a chemically balanced equation. Another dimension other than this could be, and which is also asked, is they give you certain 5 different metals, and they tell you that these are the reactions and these are the favorable products which are seen or observed after the experiment. Then they tell you, they just make blank spaces, and they ask you to align those metals from in order of most reactive to least reactive. Okay, so how do you get to know the order of reactivity? Exactly like this. Like, for example, if I say that magnesium solid is present and it has to displace zinc, so the more, if it is able to displace zinc, this means it is more reactive than magnesium. You will do it like one by one. Okay. For example, wait, let me just show a question. Yes, is the screen visible?
Yes, miss.
Okay, so for example, if you have this question, they've asked you that a table shows the observations when samarium, which is a metal, and three other metals, they are heated in oxygen. So the observations say that nickel reacts very slowly, samarium reacts rapidly, strontium reacts very rapidly, and yttrium does not react. Okay. So what do you think? Put the least reactive metal first and put them all in the order of their reactivity. What do you think would be the answer to this one? You may write your answers in the chat box, please, so I may know responses to all. Mention your answers in the chat box. Okay, Rayan says nickel and then samarium and then strontium. Yes, very good. Yes, very good, Rayan and Zoya. So most reactive is the one which is reacting very rapidly. The least reactive is the one which is not at all reacting. And the rest of them, the nickel and samarium, they're going to come in middle between the yttrium and strontium. Okay, so strontium is the most reactive out of them. Look at this one. This question says this is again about metals and the compounds of metals. Their reaction is with steam now. So put the least reactive metal first and the most reactive one at the last. Again, a similar kind of a question, only the metal names they are changed and the reaction is now with steam, not with oxygen. What do you think would be the answer to this one? Okay, Rayan says niobium, nickel, iron, and then magnesium. Yes, this is right. Yes, good, Rayan and Toya. Are you all clear regarding this one? Any questions by far? The one which is not at all going to react comes at the least reactive. The one which is reacting very rapidly, that is magnesium, will be the most reactive. The one which is reacting very slowly will be here. And the one which is reacting slowly comes here. Okay. So this is going to be your placement or the order of reactivity. Yes, this is a new question. Now, the dimension is still the same, but in the observations, they talk about bubbles which are being formed. Supposingly, they say less bubbles are formed or no bubbles are formed. This means they are coming in the category of less reactive. And if they say that the bubbles they are forming rapidly, and sometimes they say that the bubbles they are more. So the greater the amount of bubbles are, this means that more reactive the metal is. The less the reactive the metal is, the less number of bubbles will be formed, or more slowly they will be formed. Okay, you can say this. Or if they are very naive metals, you would see that no bubbles are formed or no bubbles they are produced. What would your answer be here? Lead, nickel, and then iron, and then magnesium. Yes, this is right. This is correct. Good, Zoya and Rayan. What about the rest? Are you all able to comprehend this question? Ibrahim, Ahmed, Hamdan, Ishal, Abdul Basit. Okay. एक और देखते हैं. This is a similar kind of a questions, bubbles forming. Yes, over here, this is another different question. Here, they're telling you that reactivity with cold water and with steam. From the least reactive to the most reactive, you have to arrange their order. Write your answers in the chat box for this one. You have barium, cobalt, magnesium, and zinc. Cobalt, yes. Then zinc, very good. Then magnesium, yes, and then barium, very good. The one which is not at all reacting with steam, this means it is more reactive. It is the most reactive. It is readily reacting with cold water and not at all reacting with steam. This means it is very, very reactive. Okay. But the ones which are going to react with steam, this means they are going to be less reactive than the one which is only solely reacting with cold water. Okay. Which is why barium is going to be the most reactive. So always and look into these this least reactive part and the most reactive part to be able to comprehend the question. Okay. Um, what about this? Place these metals in order of their reactivity with oxygen. Put the least reactive metal first and then the most reactive. For this, if you remember, for this kind of a question, if you remember the groupings I've told you, and that group 1 metals, they are going to be the most reactive, then group 2, then group 3, and then the transition elements. Okay. And then you have the less reactive or the naive metals or copper and all. So that copper is going to be least reactive. Then you have zinc, which is going to be in the less reactive metals. Okay. Then group 2 and group 1. So group 2 is going to be less reactive and most reactive is going to be group 1. So potassium comes as the most reactive and magnesium is going to be less reactive than potassium according to this series. Okay. So group 1, group 2, group 3. Then you have carbon. After carbon, you have transition elements, lead, zinc, tin, and iron. And then you have hydrogen, and below hydrogen, you have the least reactive or the naive metals. Okay. Similar kind of questions these are all. Tell me the answer to this one. Copper is a transition element. It has variable oxidation state. It is obtained when scrap iron is added to aqueous copper 2 sulfate. The reaction between iron and aqueous copper 2 sulfate is a displacement reaction. Okay. They've already telling you that this is a metal displacement reaction. Why this displacement reaction takes place? This is only for a mark. Okay. So a solid one statement is basically required. One simple statement. Because iron is more reactive than, yes, iron is more reactive than copper. Iron is higher than copper in the reactivity series. Yes, this is right. Both of you are correct. Then the next one, write a symbol equation for the reaction between iron and aqueous copper 2 sulfate. No word equations are required. Chemical symbolic equation is required. It must be balanced. Copper sulfate reacts with iron to form FeSO4 and copper. Yes, very good. And if you have to write a whole ionic or complete ionic equation, not half equation, only complete ionic equation, what would it be? It will be Fe plus Cu2 plus forms Fe2 plus copper. Okay, the spectator ions, they will be cancelled on both the sides. No presence of electrons within the equation. Identify another method for obtaining copper metal from aqueous copper 2 sulfate. Yes. Any method which comes to your mind? Electrolysis. Very good. The spelling is incorrect, but the answer is right. Okay. So I think I will end the session till here for now today, inshallah. Tomorrow you have a compensatory lesson and the timings is going to be wait a minute. It is 7 p.m. Pakistan time. Okay. I've looked into this as it does not clash with any of your rest of the classes. However, if anybody has any genuine reason is not able to attend the class for some kind of a reason, so you may look into the Google Classroom recordings. Okay, I will upload them. Please mention your attendance before leaving. Thank you.
Thank you, Ms. Allah Hafiz.
Bye.